Hi Doctor, in this video we are going to present our COA group project which is about CPU and hardware performance benchmark. So this is the table of contents of our presentation slides. And this is our group members. The first one is Dan Wei Jie, and the second one is Benjamin Qiu Junjie, and the third one is me, Dan Kexi, and the last one is Chen Suyan. Nowadays, computers play an important role in our daily life. Therefore, it is important to differentiate the performance of a computer before buying it. This project is divided into two parts. The first part is about CPU benchmarking and performance analysis using free tools. The second part is about writing an assembly language program to determine the execution time of CPU using different number of loops. Our project aim is to compare the performance of 4 different computers using different benchmarking tools. Besides, we also aim to run an assembly language program to calculate and measure the time taken to execute different loops for the polynomial equation on one computer. So the first objective is to understand the principle of CPU benchmarking, and the second one is compare the performance of different CPUs, and the third one is analyze the impact of different workloads on CPU performance, and the fourth objective is to learn how to use free benchmarking tools and interpret the results, and the last one is run the assembly language program and measure the execution time. So this is our group members' computer specifications. So this is the detailed information of our computer's processor type, motherboard, memory, GPU card, and also the bus specification. So the tools that we use in the first part, which is the benchmarking, is CPU Z, Geekbench, Windows Task Manager, and the last one is Mini Tool Partition Wizard.
I will do the benchmark on my laptop. My laptop is using the series the Acer Nitro AN51557 model with the processor type 11 Gen Intel Core i7. So I will show my benchmark. Those first one is CPU Z, and my main board is model Scalar TLS, and the memory I'm using is DDR4 size 60 gigs. Then I will run the CPU benchmark. So here is the result from the grid bench. So for the grid bench, we will test the single core performance and also multi-core performance. And this is the result. And this is the multi-core performance. Now I will show the task manager. You can see from my laptop, initially the task manager with the memory is 44% and the CPU is 50%. This is for the low load of the process to detect whether the memory and CPU usage. So next I will go for the middle load. So you can see my memory is up to 55%. The CPU is 18%, which is fulfill our middle load. And next I will run the high load. So now you can see my memory is up to 78%. And you can see my CPU is around 20 to 30 something. I will continue with the mini tools partition wizard this much. So this much I will test sequential and the random. So first is the sequential. So this is the result of the sequential mode. Next I will test the random mode. So this is the random mode. That's all for my benchmarking result on my laptop. Others member benchmarking result will be shown in the slide.
Okay, so this is the implementation of our benchmarking assembly program. So in the data section, this is our coefficients. Coefficient 1 is A, coefficient 2 B, coefficient 3 C, and coefficient 4 D. We have chosen A to be 8, B to be 7, C to be 9, and D to be 10. And these are the variables that we will use later in the program. And this here are the prompts that will be used to display text on the screen of the results. Okay, so here's the code. We have a repeat block here. So this entire code will repeat until the user enters in the system key, which if it is N, it will end the program, or else it will keep going. So we ask the user to enter the prompt number. So we move it into iterations, and then we get the time before the execution. So we move it to the before time, and then this is our iteration. So this constant term we move it into EX called the delay, and then move it into a partial sum. And then there's a third term, which is the term with only one x. So we multiply it. We move coefficient straight to EAX, then we move and multiply it with EBX, and then it will store in EAX, and then we add it to a partial. Same thing for coefficient 2. We move into EX, multiply it 2 times because it is x squared, and then we move it into partial. And then for coefficient 1, move into EAX, multiply it 3 times because it is x cubed, and then we move it into the partial, and then we move into EDX, and the EDX add it to the sum. And then after this, we call get n seconds to get the time after running the execution. So we move it into after time, and then here we start displaying the results. So here we display the before time. Here we display the after time, and then we subtract before time with EAX because EAX already has after time, and so we show the difference from, we then call write dec as it calls the contents like EAX, which is the difference time, and then we display the sum value, and then this is the user input if they want to continue or not. So let's see this in action. So if we enter 50, it will enter 50. It will show this. So if you want to continue, we can press Y, and then we'll bring us back here. Let's say we want to run it for 100 times. It will show this right here, the time before execution and the time after execution, and then the execution time difference. And then if you want to quit the benchmark, we can just press N, and then it will end the program. So that's it. Thank you.
This is the result of the benchmarking from the CPU side. For the core speed, computer D has the highest core speed. For the bus speed, all of the computer is slightly same. For the cache level 3, for the computer C has the highest cache. Memory, computer B until computer B, computer C, computer D have the same RAM, while the computer A have the lowest RAM. For the motherboard, each of the computer have the different type of the motherboard. And each of the motherboard can affect the compatibility and upgradability of the system. This is the performance score for the single core and multi-core, and the result we get from the grid bench. We can observe that the computer C and computer D have the highest and the better performance for the single core and multi-core, while the computer A have a better performance for the single core, while the computer B have the better performance for the multi-core. We are testing the computer performance based on the load that we assign, and this is the result from the task manager. We can see for the category low load, computer D has the lowest memory with 67%, and it consume for the CPU only 1%. And the middle load, we can see the computer D has a memory of 57%, but it's only take 2% of the CPU, which is the less CPU that it consumes compared to others. When it comes to high load, we can see the highest memories is computer B with the 83, but the CPU consume 100%. And the lowest CPU it consumes is computer C with the memory usage 71. This is a result of this benchmark from the mini tools, and this is the sequential reading mode. We can see that computer D have the better performance for the sequential reading. While for the sequential writing, computer D also perform well for it. When it comes to random type, for the random reading, we can see that computer D is high performer in all the transfer size compared to others. While for the random writing, we can also observe that computer D also get the higher performance compared to other computer. As a result, computer D is the best choice for this benchmark.
After we collect the result from benchmarking software, now we compare it across 4 computers. For the part 1, we use the free software 4 type. And now for the first type, the CPU Z, we can see the clock frequency now is the computer D have the fastest, followed by computer B, C, and the slowest one is the computer A. For the bus speed, computer A has the fastest speed, and followed by B and C have the same speed, and the slowest is the computer D. For the cache size, largest one is computer C, followed by D, B, and smallest one is computer A. For memory capacity, computer B, C, D have the same capacity, 16 gig, and computer A has smaller, 12 gig. For Geekbench, the single core score, computer D has the best score, followed by C, A, and B. For multi-core score, computer C has the highest score, followed by D, B, and A. Now for the task manager result. We can see that at low load condition, computer D has the lowest CPU usage, followed by A, C, B. For middle load, computer D is the lowest usage, followed by A, C, B. But for high load, computer C has the lowest CPU usage, and followed by A, D, and B. And the result for mini tools, we plot it in line graph, and shows here. For sequential reading, computer D has the best performance, followed by A, C, and B. For sequential writing, computer D also has the best performance, followed by C, A, and B. For random reading, also computer D has the best performance, followed by A, C, B. And for random writing, computer D has the best performance, followed by A, C, B. Now for the AF code program we write for benchmarking. Here's the line graph representing the result we running the program, the CPU at left time vs the number of loops. we find that the more iteration used, the more time is taken for the program to finish running. And also, we find that the time taken increases almost linearly with the number of iteration. To conclude the result we get from different types of benchmarking software, Computer D has the best overall performance with superior CPU and also the least performance. And Computer D has the least efficient due to the high CPU usage under high load and poor disk formation. And Computer A and C we have the moderate CPU and disk performance. My name is Benjamin. From this project, I learned how to obtain information such as hardware specification, CPU performance by using various types of benchmarking software, and also the method using assembly language. By implementing this information, I'm able to gain some insight for choosing suitable hardware and how to improve the performance of my computer.
Throughout this project, I understand there is different performance on different computers. Therefore, it is important to determine a computer's performance before buying it. The tools that I can use to determine the computer's performance are CPU-Z, Geekbench, Monitor Task Manager, and Mini-Tool Partition Wizard. Besides, the implementation of assembly code in Part 2 broadened my understanding as I learned the execution time of a CPU can be determined by the code.
So from this project, I learned how different hardware specifications affect the performance of the system, such as a number of cores of CPU, the clock speed, and the RAM size. This will help me in the future when choosing new hardware components for my computer. I also learned the different benchmarking tools that are available to analyze the performance of my computer, so I can see if my computer needs any upgrades or if there are any problems to my computer.
Throughout this project, I gained a comprehensive understanding and ability to analyze the performance of each computer. It is crucial to understand the components and specification of computers before making a purchase. This knowledge enables consumers to choose a computer that meets their specific needs, ensuring optimal performance and a superior user experience. By analyzing these computers and the benchmarking results, I have identified the specification that I prefer. This insight will guide my future purchases and allow me to recommend superior computer models with overall better performance to my friends.